Hello, in this video we are going to solve two AQA GCSE past paper questions step by step. To achieve full marks, if you just follow the steps, you will see it's not difficult at all. Just a reminder, from the previous videos we have learned 1 mole of carbon atoms, the mass is 12 gram. The number 12 is relative atomic mass or RAM, the symbol is AR, which you can find in the periodic table for each element. Using this, you can find RFM or relative formula mass. All you need to do is that add up the RAM or relative atomic mass for each of the atom of the element in the compound. Now, we also learned about the equation for conversion mole to mass or mass to mole. So from conversion of mole to mass, N equals to M over MR. So N is number of moles equals to mass divided by MR, relative formula mass. We can rearrange the equation to calculate the unknown. In this case, if it is mass, you can calculate it. Mass equals to N times MR. Keywords we learned are these: mole, mass, relative atomic mass or RAM, symbol AR, relative formula mass, RFM, symbol MR, molar mass. And if you are not sure any of these, please click on the previous videos in this playlist of moles calculation. Let's solve this problem. The question is, a mixture contains 1 kilogram of aluminium and 3 kilograms of iron oxide. They've given you the equation, chemical equation. The question they have asked, show the aluminium is the limiting reactant. They have also given you relative atomic masses of the elements that we are going to use for our calculation. Now the question is, what is limiting reactant? The limiting reactant is the reactant that runs out first and stops the reaction. From the equation they have given, we can see that 2 moles of aluminium reacts with 1 mole of iron oxide to make 2 moles of iron and 1 mole of aluminium oxide. So in front of aluminium there is 2, so that means 2 moles of aluminium, and in front of iron oxide there is no number written, that means there is an unwritten 1. So 2 moles of aluminium reacts with 1 mole of iron oxide. Okay, now this question has got 3 marks. That means we need to show our work in 3 different steps to show all the work with annotation. We are going to calculate the aluminium and iron oxide both for this understanding and finding out that the aluminium is the limiting reactant or not. Here it is. Step 1. We need to calculate the MR or relative formula mass for iron oxide, because what we are going to do is that calculate the moles of iron oxide. For that we need the MR. You remember which equation we are going to use? Of course you know that. N equals to M over MR. MR is the relative formula mass of iron oxide. So let's calculate. If you're not sure how to calculate the MR or relative formula mass, then go back to my previous videos on the playlist of moles calculation, and I'm going to explain this here as well. In iron oxide, we have got 2 atoms of iron and 3 atoms of oxygen. What we're going to do is that multiply the number of atoms with the relative atomic mass. For iron, 56 is the relative atomic mass. It is given in the question, and so we are going to multiply 56 with 2 times 2 because there are 2 atoms of iron in iron oxide, plus 16. Relative atomic mass of oxygen is 16 times 3 because there are 3 atoms of oxygen in iron oxide. Altogether, if we add up, we'll get 160. So if you can do this, you get the first mark. We are going to use this for calculation of moles of iron oxide. 3000 because in the question they have given you 3 kilogram, we need to convert it to grams, and 3000 divided by 160, the relative formula mass of iron oxide, we get 18.75 mole. If you can do this, you are going to get the second mark. Okay, so which is this. And the formula I've shown you here, N equals to M over MR. This is the equation we are using. Same method for calculating moles of aluminium. 1 kilogram of aluminium is given in the reaction mixture, so 1000 converting to grams, 1000 divided by 27, relative atomic mass of aluminium, you get 37 moles. Now, these two, calculating both of these is 1 mark, and third mark is to find out whether the aluminium is limiting reactant or not. From the chemical equation given in the question, we can see 2 moles of aluminium reacts with 1 mole of iron oxide. So the molar ratio of aluminium and iron oxide is 2 to 1. So if it is 37 moles of aluminium reacts with half of iron oxide, that is 18.5 moles of iron oxide. From here, we can say that 37 mole is less than 18.75 times 2, 37.5. Or you can calculate it other way. Iron oxide is in excess because 18.75 mole is more than 18.5 moles. So that gives us our third mark. Okay, so show all your work step by step to show aluminium is the limiting reactant. That means it is less moles available and it will react fast and stop the reaction first. Okay, brilliant. Next, we are going to discuss about the common mistakes examiners see in final GCSE question with this topic of mole calculation and how to avoid these. First thing is to be aware of these mistakes and practice loads of past paper questions so that you do not make the same mistake in your final exam. If you follow these strategies, you can achieve full marks in moles calculation topic, which is one of the most important topics in chemistry because you get questions in GCSE every year. And it is not as daunting as we think sometimes. So let's go through it together. One mistake people do is not showing their work. Only writing the final numbers will lose the method mark. If there are 3 marks, you are expected to show all the calculations in 3 steps. Normally 2 for the steps and 1 last mark for showing the final answer. So keep this in mind. With this strategy, you will not lose any mark for the method especially. Also, even if your final answer is incorrect, you can get the method mark if you have shown it correctly. So normally you can get 2 marks out of 3 if the final answer is not correct. So for example, if you're finding mole, write down the number of mass divided by MR. This is one important thing to remember. So don't make that mistake, not showing any work, just showing the numbers. You will lose the mark for the methods. Second type of mistake people do is misreading the question. Read the question very, very carefully to note whether it is the moles given or the mass. And same for the final answer. What they have asked, is it moles they have asked or mass? So convert it accordingly. Third type of mistake that is normally people do is that incorrect use of molar ratio. from chemical equation. Check if the chemical equation given, is it balanced or not? If you have to write your equation, then also check whether it's already balanced or you really have to do the balancing of the equation. So I have given you the steps for moles calculation questions. So normally we do it in 4 steps. First, check the equation is balanced or not. Otherwise, you will get the moles ratio incorrect and the rest of the calculation will be not correct. Then step 2, you find the moles ratio from the balanced equation and you calculate the moles from the mass if mass is given. Step 3, you calculate the relative formula mass from the relative atomic mass if you need to. So it depends on the question. These are just general steps. And another thing to say that depending on the question, you can do the step 3 first and then the step 2 so that it is easier for you. But follow these steps thoroughly, then you are not going to lose any marks. Then step 4, read the question carefully if they have asked the mass. So from moles, convert it back to mass again. So doing lots of past paper questions builds exam confidence. With this knowledge, we are going to look into the next past paper question from AQA, recent AQA past paper questions, and we are going to see how we can avoid these kind of mistakes. The second question we are going to do is a practical question. So let's read through it together. A teacher investigated the reaction of iron with chlorine using the apparatus. The word equation for the reaction is given. Iron plus chlorine makes iron chloride. The teacher weighed the glass tube and iron before the reaction, the glass tube and iron chloride after the reaction. And all the data is given into this table, all the mass they have measured in gram. Now the question they have asked, calculate the simplest whole number ratio of moles of iron atoms to moles of chlorine atoms. Determine the balanced equation for the reaction. They have also given you relative atomic masses of chlorine and iron that we are going to use in the calculation. So there are 2 parts of the question, and the whole question, this one has got 6 marks. And if we see the mark scheme, we'll know that the calculation, the first part of the question, to calculate the simplest whole number or ratio is 4 marks. And then the second part, determine the balanced equation for the reaction, that is 2 marks. So let's do step by step. Now they have given you the word equation and what they're expecting you to write down the balanced equation. So what you need for this is to know the moles of the reactants that have reacted. What is given is the mass of glass tube and the mass of glass tube plus iron. So what you're going to do is that subtract 51.56 from 56.04. We can get the mass of iron used in the reaction. So here it is 4.48 gram, that is for the iron. Similarly, we can find out the mass for the chlorine. So what we need to do, glass tube plus iron mass, that one, from glass tube plus iron chloride. So we get 8.52 gram, that is for chlorine. By showing both of these answers, you can get 1 mark, but you need to do both of them correctly to get the full 1 mark. Now, next step, what we are going to do is that convert the mass to moles. Which equation we are going to use? Of course, you know it. So N equals to M over Mr. So for calculating the moles of iron, 4.48 the mass, divided by 56, the relative atomic mass, and you get 0.08. Next, moles of chlorine, you got the mass 8.52 divided by 35.5 and you got 0.24. So these, each of them, you get one mark for calculation of the moles. Okay, so that's quite easy, not difficult at all, isn't it? All you are doing is that first thing is that to understand the question, they have given you the data and you subtract the mass to find out the mass of iron and chlorine both. Then you are converting all of these, both of the mass from to the moles of both of them. Now the next step is to find out the molar ratio, isn't it? So we got the moles. So put those numbers next to each other, iron to chlorine and 0.08 to 0.24. What do you get? You get the molar ratio, that is 1:3. So that means 1 mole of iron reacts with 3 moles of chlorine. So from there, what you get, the compound is FeCl3, right? So what you do is, next step is to write the balanced equation. So write down, they have given you the word equation, iron reacting with chlorine, and you get FeCl3. You balance that equation. So with that, you get 2 marks. So molar ratio, you get 1 mark, and then last 2 marks of the 6 marks is that writing the balanced equation. Okay, so we have done well on this question, isn't it? We can apply the practical skills to calculate molar ratio in the chemical reaction and ultimately writing the balanced equation. Well done. Now don't miss the next videos to solve more past paper questions like this and to be aware of the exam tricks. Keep practicing chemistry, keep shining. All the best.